Sure. So I see Cameron's got a question here. That's the first question I've got so far. So let me just say a few things, and other people can let me know if there's other things you want to look at. So there's 3 homeworks, another 3 homeworks due next Wednesday night, and I'll remind you again that we'll have our first test on Thursday the 23rd. The trig formulas homework was due last night, but then I extended it until tonight because we were supposed to finish talking about the trig formulas, or you were supposed to finish watching the video for today, and then we could finish talking about it today. And so I had left it up there for a while with the due date of last night, so that hopefully when you went and looked at it, you would try some of those problems. Didn't really work. Most people just kind of blew it off, but what can I do? So there's another homework due tonight. If you weren't aware of that, it's the trig formulas homework that people have left most of those to do. I'm happy to talk about some of those questions. I see Cameron has a question about the lowering and half angle formulas. Let me go ahead and take that page out of the notes here. So that's on page approximately 72 is where that section starts. And in section 2, or 72, I mean, we have some more formulas. And so the first set of formulas is what to do when you have 2 times something inside a sine, cosine, or tangent. Page 73 talks about how you can take cosine, sine, or tangent that have powers and make them powers of 1. So if you want to like lower the powers on your trig functions, you would use that formula. And then the third set of formulas tells us what to do with something divided by 2. And so when we're looking at these formulas, the double angle formulas and the formulas for lowering power, in my opinion, are less useful than the half angle and addition subtraction formulas. So, you know, the 2 that are on the page right now, these 2, the double angle and the lowering powers, these are mostly used in proofs, and they're occasionally useful in solving problems, but they're not terribly useful is the way I would describe it. But the half angle formula we can use to evaluate weird degrees like we had done with the addition subtraction formula. For example, if we want to figure out tangent of 15, we don't know 15 on the unit circle, but 15 degrees is 30 over 2, and we know 30 degrees. And so that's sort of the way we talked about using these formulas in the video. And so let me take a look at the question that was asked specifically. I'm happy to go over the notes if anyone has a specific question about the notes. Maybe I should just start there while I pull the web work up. Does anyone have a specific question about any of these notes that you'd like me to look at? Again, I'm pulling up the web work right now. Give me just a second. So Cameron had asked about problem 8. Let's see what that one looks like. Okay. So problem 8 in web work, I'm assuming this is the one you're talking about. Let me know if I'm wrong. So trig formulas, which is due tonight. Again, this web work is due tonight. And we looked at a couple of these in class yesterday, by the way. So if you're still confused about this stuff, you might want to review the notes I posted from yesterday and potentially the video from yesterday. So this is problem number 8, and it says cosine of 22.5 equals something that looks like this.
Hey, Professor, could I mention that what really hung me up was the fraction before the entire square root, and then b was square root. So I was like confused trying to pick up what equation I went over on the video.
Okay, sure. And so it's sort of telling us that the answer is going to look like this, and then it specifically says use a half angle formula. It's obviously cosine, right? Because it's cosine of 22.5. And so when we look at the half angle formulas, we're going to want to use the cosine cosine 1, I want to think about 22.5. Like, this is the part we're given. We're given the u over 2, the cosine of u over 2. And so we want to think about, what is u? In other words, what would I need to divide by 2 to give me 22.5 is what we're thinking. So we're thinking about
45.
Right, yeah. And so the other way to say that is you just double 22.5 to get u, right? So cosine of 22.5 is the same thing as 45 divided by 2. And then this becomes the u in the half angle formula. Well, let me put the formula up again. So now when we wrote 22.5 as 45 over 2, now it looks like this. It looks like something divided by 2, right? And then over in the formula, you just use u, right? So the u over here is going to be 45, and we know cosine of 45. Right? So I'm going to use this formula and then write this down. So this is going to be plus or minus the square root of 1 plus cosine of 45 degrees. And just pause there and let my dog finish barking. Does that seem okay so far? I'll take the formula away. And so then we know cosine of 45 degrees, right? For cosine of 45 degrees, we go to 45 degrees, and we use the x value. And so 45 degrees, the x and the y value are the same. And so that's where the inside square root is going to come from. And so we use the x value, and so this ends up being cosine of 45. And so this ends up being, and what are we told here? Oh, 22.5 is in quadrant 1, right? And so we're also going to take the plus version of this. So I'm just going to do plus 1 plus root 2 over 2 over 2. And then we just want to simplify it, right? So we know the answer looks like this. And so that's sort of what we're heading towards. It's seeming to me like the inside square root is going to be square root of 2. And it seems like this a is going to be whatever constant we end up with. So let's simplify this by dividing this 2 into both terms. And so this becomes square root of 1/2 plus square root of 2 over 2 over 2. And this is like a 2 over 1. And so you would flip this bottom one and multiply it by the top. And so this is really 1/2 plus square root of 2 over 4. Question so far? We don't quite have it looking like this, but we're on the right track here. So I'm going to add that fraction. Right? These is two fractions. I want this to have a common denominator, so I'm going to make the denominator of this one a 4 by multiplying by 2 over 2. And so then this becomes 2 plus root 2 over 4 inside the square root. And now we almost have it. We know from the first section you can break this. I'm just doing all the steps here. I hope this is okay. You can break the radical up like this. This is what we learned in the very first section of this semester, is you can take a fraction inside a radical and break it up like that. And so then this becomes the answer. Another way to maybe write that, I don't know if that looks good to you, but this is the 1/2, right? So this is also 1/2 times this. And so now this looks like the answer, with A being 2 and B also being 2.
Could you repeat that? I'm a little hung up where it goes from entire root 2 plus root 2 over 4. Like, how do you do that?
From here to here?
Yeah. And for continued on to the rest of the equation.
Sure. So the thing we learned in the very first chapter with exponents and radicals was if you have a radical like this, you can break it up into two. You can apply the square root to both pieces, basically. And so that's what we're doing from here to here, is we're taking the outside square root and applying it to both the top and the bottom. And then we can take the square root of 4, right? The square root of 4 is 2. And I'm trying to make it look like this, the answer that they're telling us. And so I'm just trying to make you realize that dividing by 2 is the same thing as multiplying by 1/2, right? In other words, if we want it, this is this over 1, right? So if we multiplied this fraction by this fraction, the 2 and the 1 would multiply to give you this, and the numerator and the 1 would multiply to give you this. And so I'm just, again, I'm trying to make it look like the answer that they told. They're all these things are correct, to be honest with you. And if this is a test, anything that I'm boxing in right now would be a perfectly fine answer. It's just when you're doing this online, it wants it to look like a certain way. It's like telling you the answer, and then you're trying to make it look like the answer, basically. But on a test, I just want to see that you can use the formula and simplify a compound fraction, right? So I want to see you get rid of the compound fraction here. But once you get rid of it, like, this is fine. This would be a fine answer. You're welcome to add the fractions. Like, any of these things in there would be a fine answer on a test.
Okay, thank you.
Other thoughts about this one? Can I clarify anything out there?
I had a weird one, Dr. Levy.
Sure.
Right where you have that plus the square root of 1 plus root 2 over 2, and you separate it.
Yep.
Even when, never mind. I think I just answered my own question.
Let me just say something about that anyway, because that's a common question. We've done that a couple times. This is not the first time we've seen that. What we're doing here is we have 2 things being added in the numerator and 1 thing in the denominator. And so what you can do is you can break that up like this, is the idea. And that should make sense, because if we started with something like this, they have a common denominator of c, right? And so you could keep the common denominator and then add the top. And so usually we talk about going from something with a common denominator to adding the top. But the interesting thing is you can go the other way too, right? You can start with something like this and then break it up. And so that's what we're doing from here to here, is we have the c in the bottom and it's dividing both the terms.
Yeah, I was just answering my own question. I forgot that when you divide a fraction, I forgot about the flip part, because I'm thinking, yeah, I'm overthinking it. My bad.
Okay, yeah, so that part then, yeah. So then you have a fraction divided by a fraction, and I'm just going to say this for anyone else who's curious about that. And so then you flip this and you multiply it, right? And so the 1 is going to multiply the square root of 2 and stays the same. And then this 2 is going to end up multiplying that 2 to give you the 4, just in case anyone else was thinking about that.
Yeah.
There's a lot of algebra in that one. You know, I did try to warn us sort of early on that, like, we need to be good with fractions, right? Because when trig comes around, there's lots of fractions, and I wasn't lying. Okay, thank you for those questions. I'm happy to keep clarifying this one. Are there other parts of the notes or other homework questions that you're interested in looking at instead? Happy to do whatever would be helpful for you.
You okay with doing number 9, the same web work?
Sure.
Hold on.
So let me just show you where. Let me write the question down.
It's on my shoulder. Huh? Hold on. Give me something.
So number 9 says it gives you a value for sine. And then it wants sine of 2x, cosine 2x, tan 2x. And so this is begging us to use the double angle formulas, right? If we want to know sine of 2x, cosine 2x, tangent of 2x, that looks just like the double angle formulas, right? So if I look over here, that looks like the left-hand side of these things. And so if I want to be able to do those things, I just need to know what sine and cosine and tangent values are. And so we want to use the double angle formulas. But we need the values of tangent, sine, and cosine. And we're given one of those, right? So we know sine. We have this one already. Because that was what we were given. So we have the sine one. We just need to figure out what cosine and tangent are from that. We did one on this. We did one like this actually right below this, right? So here's the double angle formulas on the page. Right below that is a similar example of this, where you're given a tangent value, and then you're asked to find the other ones. And so the idea is we're given two sides of the triangle, because we know that tangent is the SOHCAHTOA part of it. That's the TOA part. And so we know tangent is opposite over adjacent. And so when you're given two values, you're being told two sides of the triangle. And so in this particular one, if our x is right here, if our angle is in this corner, then opposite is here, and adjacent is next to it, right? And so that's how we got 4 on this side and 3 on this side, because we were given those two sides. And then once you have two sides, you can find the third side using Pythagorean theorem. And so then you have all three sides, and then you can figure out cosine and tangent and plug them into the formulas. So that's sort of the process. I don't know if I want to do all this one, but I'll at least get us started and enough that you feel comfortable doing it. So we're being told that sine is minus 3/5. So since sine is minus 3/5, are we being told a quadrant? Oh, we're in quadrant 3, right? So that's why sine's negative. Sorry about that. So since sine is 3/5, we draw a right triangle, and then we label two of the sides 3 and 5. And so I know sine, that's the SO in SOHCAHTOA, that's opposite over hypotenuse. And so we're being told the opposite side is 3 and the hypotenuse is 5. And so if I put my x right here, then opposite that is here, and hypotenuse is always right there. And so we write two of the sides, and then we find the third side by doing a squared plus b squared equals c squared. And so that's gonna, once you solve that, you'll figure out that b is 4. This is a 3, 4, 5 triangle. That's a very common triangle. And so then you can, so this side is length 4, right? And so then you can figure out tangent and cosine. Right, so cosine of x, that's the cut. So that's adjacent over hypotenuse. And if we're here, adjacent is 4 and hypotenuse is 5. Questions so far? Okay. Let's keep in mind, though, we're in quadrant 3, right? And in quadrant 3, x values are negative. And so cosine's negative in quadrant 3. And so really cosine is minus 4/5. And so this is what we're going to use for cosine. And then we do a similar thing for tangent. So tangent, that's the TOA part, right? So that's opposite over adjacent. And if this is the x value we're talking about, opposite is 3, adjacent is 4. So we'll get 3/4. And tangent is positive in quadrant 3. So we don't have to mess around with that one. So we're just going to use 3/4. Okay, let me stop there for a second and see if that anyone is not following along and wants me to clarify something there.
What side of a triangle correlates the equation you needed above? So a squared, b squared, c squared. What side correlates for what letter?
So good question. All that matters is that C, what goes on the right-hand side, has got to be the hypotenuse. A and B you can switch, right? Because these are just both on the left-hand side, so it doesn't matter what order they're in. But you've got to put the hypotenuse on the right. So when you do a squared plus b squared equals c squared, the C has got to be the hypotenuse. That's people mess that up all the time. Like some people might have been thinking this was 3 squared plus 5 squared equals b squared or something. But you're going to get a totally different answer if you do it that way. So you've got to have the C as the hypotenuse. Other thoughts? Other questions so far? So to kind of to summarize, we were given a value for sine. We want these values, right? Sine of 2x, cosine 2x, tangent 2x. So we needed to figure out tangent and cosine. And so we drew the triangle that we were given based on sine and then found the third side using Pythagorean theorem. And that let us write down cosine and tangent. And then we can just use the formulas, right? So now if we want to do like sine of 2x, we just do 2 sine cosine. So I'm not going to do all of these. I'll just do one of them at least. So now the one final answer. If we want to do sine of 2x using the double angle formula, that's 2 sine x cosine x, and we have each one of those values, right? Cosine was minus 4/5, sine is minus 3/5. And so this is going to be 2 times minus 3/5 times minus 4/5. And you just multiply straight across. WebWork will probably accept that, but if you want to simplify it, this is a 2 over 1. And so you do 1 times 5, which is 25. And then the negatives cancel out, and you do 2 times 3 times 4. So that's 6 times 4, which is 24. Excuse me. So that would be the answer to the first one. That would be sine of 2x, for example. Cosine of 2x would be similar. Tangent of 2x is also similar. You just need to use those formulas. What can I clarify about that?
Like quick and briefly, could you tell me how you declared that cosine was negative in quadrant 3 and tangent was positive?
Sure. So there is a page in the notes that sort of mentions where things are positive, but I would just recommend using box number 1. I haven't said that in a long time. Box number 1, box number 1. I got to really make up time on that. Box number 1, box number 1. We got to use box number 1 for almost everything in trig. So box number 1 tells us that sine is the y value on the unit circle. It tells us cosine. I don't want to put an x in there. I don't want to be confusing. I'll put a theta or something. Put a t. Is the x value. And for tangent, you divide y by x, right? And so if we're on the unit circle and we're in quadrant 3, that's down here, then the x comma y, the x's are negative and the y's are also negative. And so whatever x value you choose here is going to be negative. So that's how we know cosine is negative in quadrant 3. Whatever y value you use is also going to be negative. So that's how we know sine is negative in quadrant 3. You divide the two of them for tangent. And so when you divide two negatives, they cancel into a positive. And so tangent's going to be positive in quadrant 3. That's how we knew that. And so it's all based on box number 1, which you will have on the test, and just knowing pluses and minuses on the unit circle, right? Box number 1 in the unit circle really, really, really does guide almost every answer in trig. So maybe just to drive that home again, like if we were in quadrant 2, that's up here, x comma y in quadrant 2, the x is negative, but the y is positive. And so in quadrant 2, cosine's negative, but sine is positive. And then if we divided the two, we'd also get a negative. Right? So you can reason through absolutely any of them sine-wise using that concept. What else can I help with right now? I really hope this is helpful. I hope we can get everyone through this course. I'm going to feel bad if people sort of don't make it through, but I'm trying real hard to make this happen, and I hope you're trying too. And I would love to keep helping you if anyone has those issues. I know you're each dealing with your own separate thing at home. I know a lot of you might be working in crowded spaces with lots of people around and things like that, and I know it can be tough. So I'm happy to be flexible as much as humanly possible. So if you need some extensions or whatever, that's fine. Just let me know. But we have less than a month of school left, or about a month of school left, I guess, at this point. And so there's not that much time to keep pushing things off, right? You need to kind of figure out a good schedule for yourself. Use me as a resource as much as possible. Very few people are sort of reaching out during the day for help, and I'm always willing to do that. But anyway, just do whatever you need to do to get past here, and I'm happy to help. Anyway, is there anything else people would like to talk about at this time? Happy to keep going here.
Hey, Dr. Levy, I had a
Yep.
question. So, oh dang it, where did I put my notes? So for the cosine 2x, would that be like if the form? I just had it. I'm looking over 'em. So if that was so with those same numbers, if it was asking for a cosine of 2x, will we just be taking that fraction and squaring them? I mean, like.
Yes. Yeah. Right. So if
Like-
it's a square, then you're just squaring the fraction. And I should mention too, cosine has 3 options, and it doesn't matter which one you use. But there is a square in each one, like you mentioned. Yeah. So if you were going to do I'll just maybe squeeze it down here just to be clear. If you did cosine of 2x, that's going to be cosine squared minus sine squared. And so that would be, in this case, minus 4/5 squared minus 3/5 squared, like you said. And so then you'd square each number inside there. The negatives would go away. You would have a common denominator, which is nice because they both have a 5 down there, which will turn into a 25. And yeah, so you square both numbers. That's right.
All right. I just wanted to make sure that's.
Yep.
Making
No,
sure that's.
Sure.
All right. Thank you.
Other questions? I'm also open to hearing other ways that I might be
Professor
helpful
Levis?
to you. Yeah. Do you have a question? Thought I just heard someone talking.
Yes, I do.
Sure. Go ahead.
It's Ramon talking.
Hey.
For question last night, Trig and in this, that was the box we gotta use, box number 1 that you're mentioning right now.
You want me to show you box number 1?
No, now that you mentioned box number 1, I was a little off for problem 10
From the trig
in
formulas?
trig identities.
Trig
I was
identity. Sure. 1
confused.
second. Let me pull that up.
Yeah, and problem 10. I was
Trig
confused.
identities, problem 10.
For the final.
All right. So trig identities, problem 10 looks like this.
You
It
talking
says
right now.
tangent of u plus cotangent of u equals something underneath a 1. So it'll be, in other words, it's telling you to start with tangent of u plus cotangent of u. And when you simplify it, it'll simplify into 1 over something with a u in it, is sort of what that's saying. So, okay, go ahead. What was your question? Do you want me to just work it, or do you have a specific question? I'm not sure if you're trying. Yeah, I think you're muted. Do you want to say that again?
For me.
Do you want me to just work it? I can't understand what you're saying.
Work it out.
Okay. So let's do that. So we know that
Work it out.
tangent is sine over cosine.
Sorry, my
That's okay. I'll work it out. If you get cut off, this is being recorded, so I'll just post it on YouTube. You can see it later if you need to. Anyway, tangent is sine over cosine, and cotangent is the flipped version of that, right? It's cosine over sine. And so when you make those two substitutions, you get sine over cosine. And I'm going to leave some room here because we're going to want to do a common denominator here. Over cosine over sine. So we want to add those two fractions together. And, how do I know we want to add them together? Because there's really nothing else we can do, for one thing. But the other thing we know is that it ends up being one fraction, right? And so I've got two fractions, and so we want to combine them into one because that's what the answer looks like. And so I need them to have the same denominator. So I'm going to give this one a sine by doing this. And I'm going to give this one a cosine by doing this. And when you do that, the denominators end up being sine times cosine, right? You get a common denominator, in other words. And when you multiply the tops, you get squareds, right? So sine times sine is sine squared. And cosine times cosine is cosine squared. And I'm going to go ahead and add the fraction together. Oops, it's multiplied, not plus on the bottom. Okay. And so we're almost there, right? So we have one fraction, and it looks like the answer is one fraction. And so now we just need to convince ourselves that the top is 1. Well, we know from the Pythagorean identity that sine squared plus cosine squared equals 1, right? So this just ends up being 1 over cosine u times sine u. And now it looks like the answer, right? It says the answer is going to be 1 over some function with u in it. And the function that we're dealing with is cosine times sine. And so in our answer, the f of u is cosine times sine. And that is the answer. Let me just sort of remind you, we've been working on a couple of these over the last couple of days. The way you think about these problems is you're being told the answer, right? You're being told it's going to look like this. And you want to use the fact that you know the form of the answer to sort of guide you along the way. That's how I knew that we wanted to add the fractions. That's how I knew that the bottom seemed okay because we were looking for a function of u. And that's how, if you forgot about sine squared plus cosine squared equaling 1, we know that there's supposed to be a 1 in the top. So we're trying to think like, how do I change this into a 1? Oh, right, that's right. It just equals 1 because of the Pythagorean identity. So knowing the answer, in other words, helps guide you along the way. I really try to emphasize that in the videos. Questions about that one? I'm happy to clarify more about that if anyone's got something or another one.
No, you clarified. Thank you. I do have another question from the same homework, which was problem 11.
Okay. So number 11 looks like this. It says 2 plus tan squared over secant squared minus 1 equals something squared. So that's how you want to be thinking about that. So you're going to start with the left-hand side, and you're going to simplify it down, and it's going to end up being something squared. And then it wants you to enter the something. And so let's start with the left. I'm running out of room here, so I'm going to go ahead and change tangent into sine over cosine. So the substitutions I'm going to do are tangent is sine over cosine. And we know that secant is 1 over cosine. I'm just going to mute you, Ramon, quick, just because there's some sound coming there, but feel free to unmute yourself if you want. If you have a question, that is. So tangent becomes sine squared over cosine squared, right? Because it's being squared, so you just square both those things. Maybe I should mention that. If tangent is sine over cosine, then tangent squared just squares both of those. And if secant is 1 over cosine, secant squared just squares both of those, but 1 squared just stays 1, right? So it does that, and so you just end up with this. And so those are the substitutions we're really making. And so I've got the first one written down. And then the second one would be 1 over cosine squared. And then we've still got the minus 1. Okay, so then we're dividing by a fraction. So we're going to flip this, and we're going to multiply it. And so when that happens, it looks like this. And so I flip the cosine, the 1 over cosine squared, and I'm multiplying it. And it's going to distribute through here, right? It's going to do this, and it's going to cancel this denominator out, and then it's going to multiply this one times 2. This one is a tricky one. That's why it's the last problem, I guess. And so when we do that, we end up with 2 cosine squared plus sine squared minus 1. So there's a couple things we can think about doing here. Right, we want this to equal like something squared. And we've got some squareds going on, but we just want one thing squared. And so, you know, whenever you're thinking about trig functions being squared or the number 1, right, sine and cosine, you should be thinking about the Pythagorean identity, which comes up almost every time, right? It came up in the last time, so we're going to use that thing again. It comes up in most proofs, I think. So we know sine squared plus cosine squared equals 1. And so there's a bunch of things we could do using this. Like we could figure out what to do with cosine squared using this. We could replace the number 1 with sine squared plus cosine squared. Or we could rearrange this formula to do something with sine squared, right? There's lots of ways that we could deal with this. I don't know, is there one that's sticking out to anyone in particular that you want to try? We want to use this in here somehow, though. Yeah, if you care. If not, I'll pick one.
So you're asking me? Have you?
So why don't let's find an expression for sine squared, right? Let's get sine squared by itself right here. So let's subtract cosine squared, in other words. Maybe that's the easiest thing to do. And then we can see that sine squared equals 1 minus cosine squared, right? We've seen that a couple times before. And so we can take that and plug it in here. And then we're going to be right at the answer when we do that, because this is going to be 2 cosine squared plus 1 minus cosine squared minus 1. Right? I just replaced that with this. And then things simplify down right away. Right? Like the 1's cancel. You have 1 minus 1. And so the 1's are going to cancel. And then you have 2 cosine squared minus 1 cosine squared. Right? It's like a 2x squared minus 1x squared equals cosine squared. And that looks like the answer, right? We were being told the answer is going to be something being squared. And so the something that's being squared is cosine. So you would enter cosine here because it just wants you to enter what's inside the square. That was absolutely the trickiest one in this. That's why it was the last problem. I think it was the trickiest one, at least. I don't know.
Quick note is that I did this with Zachary, the tutor you have for Mondays and Wednesdays, Tuesdays,
Yep.
Thursdays. And I forget what process we did it quite exactly, but we got the answer for absolute value cosine x.
Yeah, I saw that in your answer. I was wondering where that came from. Maybe you use one of the other formulas. So one thing to realize is there's lots of ways to approach these things. And so maybe you rewrote, like in box number 1. Let me pull box number 1 out. Do you have what you did? Do you remember what you did?
I can dig up my notes to actually state it, but just give me like a few minutes. But
it's not a big deal. That's technically, I don't think it needs to be an absolute value. I had seen that you did that, but you don't need it. My guess is you used something from box number 1, which I'm trying to find. I'm sorry, not box number 1. It would be the Pythagorean identity. You probably used something in here, would be my guess. I think you probably did, maybe you replaced secant with tangent plus 1 or something like that. Or, yeah, I'm not exactly sure. You got to the correct answer, though, and there's lots of different ways to sort of approach these problems, I guess, is the takeaway there. What else can I help with today? I mentioned a second ago when right before Ramon asked that, I'm happy to help in other ways. Like I'm trying to be as helpful as I can. I'm trying to post these videos both from class, but also these help things. I'm trying to give you lots of practice problems and stuff. Is there something else I could do that would be helpful?
I got the process how I got that answer.
What was your first substitution, just out of curiosity?
I was pretty much the exact same thing. So when I got towards the end, what you just wrote, which was cosine squared of x equals f squared of x. He had me get the square root of the equation. So the square root of cosine is just absolute value.
Oh, so I think that's a little bit of I think maybe that's a little bit of a misunderstanding. What this problem is saying is when you simplify this down, you're going to end up with something being squared. So it's not like you set this thing being squared equal to cosine squared. It's the thing being squared is cosine. So in other words, you don't want to, it sounds like maybe you did this. And then you square rooted and you got this.
Yeah, absolutely. That's literally what I did.
That's not quite right. So the answer, it's just telling us like the answer is going to be something squared. And then when you get something squared, what is it being squared? That's sort of the correct way to do it. It accepted cosine absolute value because it's a similar answer, I guess, but you don't need the absolute value, I guess, is what I'm trying to say.
Regarding the exam, what step I do, it'd be the one we just went over, correct? Not the absolute value answer?
Correct, right. And also to be clear, on a test, the way this would be phrased on a test, it would tell you cosine squared. It would say, the test version of this would be, prove that 2 plus tangent squared over secant squared equals cosine squared. So it literally like tells you the answer, and then you start with one side and you transform it into the other side. You can't do that online because if it just told you the answer, there wouldn't be anything to do, right? So the way it works online is it says like simplify this down and you'll get something squared. But on a test, I'm going to tell you the answer. I'll tell you it's cosine squared and just want to see that you transform it into that. And so maybe that's a little bit easier. I don't know, because you kind of know what the answer is in some sense.
Thank you, Professor.
Sure. Can I answer some other questions here? More than happy to. Or again, I'm more than happy to take suggestions of other things that would be helpful. I don't know what else would be helpful. I'll just remind you again, I'm around throughout the day, potentially in the evening. I've met with Cameron in the evening once. Like it's easy to pop on here and answer homework questions. So please take advantage of that if I can help. Okay, well, if there's nothing else right now, I'm going to post this video on YouTube. Feel free to revisit it